All right, good morning, Green Nines. I apologize for not being able to be there today, but I am a little bit sick and not able to make it in. So we are going to try things a little bit differently today with a little recording of the lesson. All right, I'm going to get started right away here because I have had some technical difficulties, and so I'm going to try to do this in one shot with as little issues as possible. So here we go. Let's make sure we all have our worksheet in front of us for today. It says initial value, slope, partial, and direct variation. You should have been given that, and here we go. To begin with, we are going to start with determining the slope. Little example from yesterday, little recap. Okay, if we want to pause the video, you can try these. You can pause the video now if you would like to try these. Okay, I'm going to continue here, whether or not you tried them or not. For the first one, we are looking at the slope from a graph. When we're doing that, we are finding 2 points, and I am connecting these 2 points with a right angle triangle. We use this triangle to find our rise and to find our run. Our slope is equal to rise over run. We did this yesterday. Okay, my rise in this question is 1, 2, 3, 4, 5, 6. So my slope is 6 over my run, which is 1, 2, and 3. That is a slope of 2, and you can simplify that to 2 over 1, or just write it as 2 over 1, or just 2 if you would like. Okay, that's my first one. Use your triangle to find it out. My next one, again, we're going to go through this a little quickly here. We are going to find my change in y and compare that with my change in x. What is each variable changing by? On the right, we see that we're changing by -10 each time. On the left, we can see that we are changing by 2 each time. Your slope, in this case, is equal to rise. Oh, I'm going to correct myself here because that is not what it is. It is our rise. Oh my gosh, why did I say that again? It is our change in y over change in x, which is equal to -10 over 2 or -5 over 1. Okay, keeping rolling along here. For this last example, I'm going to do this in my favorite way to do this, which is just stacking these, okay, called the stacking method. We're going to go x and y. We're going to kind of create a little table of values. 5, 7, that's my first point, right? There's that point there. My other point is 8, -2. There's that point there. And all I'm going to do is I'm going to figure out what is this changing by, which is -9. What is this changing by? That's +3. My slope is equal to my change in y over change in x, which is equal to -9 over 3 or -3 over 1. Okay, we're reducing that fraction. All right, we're going to keep rolling here. We are about 3.5 minutes in. Last time I ran into issues around 10 minutes. So we are going to see if we can get through more of this. All right. Now we're going to talk about initial value, which is one of the key terms, definitions that you have on your sheet. You can copy that definition down now. If we need to pause the video, please feel free to pause the video at any point here. The initial value is the starting point of a graph. Okay, it's the starting point of a graph. Okay, it is the point on a graph that is on the y-axis. It's the point that's on your y or vertical axis. It is also the y-coordinate when the x-coordinate is 0. Okay? So if we look at our coordinates in a table of values, when x is 0, it's the initial value is your y value when x is 0. So again, if we need to pause this for people to get this copied down, feel free to pause. I am going to do a couple examples now. The first example, we are looking at where my graph crosses my y-axis, or where it crosses my vertical axis. That is this point right here, which is an initial value From now on, I'm going to use IV for short of -4. Excuse me. That's -4 right there. Notice that that is when my x is 0. Okay, x is 0, my y is -4. If we go over to, right, if I were to write the coordinate down there, the coordinate of that would be 0, -4. Okay. If I look at my table of values, we are looking, when is my x 0? It's right there. And what is the corresponding y coordinate? It is right there. And so for this second one, my initial value, or my IV, is equal to 60. Okay? Rolling right along here. Again, feel free to pause at any point or go back. Okay? We're going to look at some initial values from some graphs. Like I said, I am going to write IV for short. So for each of these, we are just going to put IV and just write what that is. Again, your key right now is just identifying what the initial value is. Let's zoom in on this one. Where does my graph cross my y-axis? It crosses my y-axis right here. That coordinate is 0, 0. But for our initial value, all we care about is the y coordinate there. And so my initial value here is 0. Okay, moving to my second one. Again, we're going to look at where my graph crosses the y-axis. In my second one, it crosses the y-axis right here. Okay, in this one, because it's kind of in between two numbers, 20 and 30, we're going to estimate that. This coordinate I'm going to say is about 0, right? 0 on my x-axis. And I'm going to say about 25 on my y-axis. Now, we only care about the y coordinate there. So I'm going to write that my IV, my initial value, is equal to 25. That's the starting point of that graph. Moving over to my third one, we have, again, we look at where my graph crosses the y-axis, which is right here. If I were to write that coordinate, it would be 0, -5. We only care about the y piece there. So my initial value, or my IV here, is -5. Okay, I'm at 7.5 minutes. We're doing pretty good. Again, if you want to take a look at those, we got 25 and we got -5 there. Okay, let's scroll down. Now we're going to look at it based on our tables of values. Now the first one's really straightforward. We're just given the coordinate. Again, we're looking for when x is 0, and I look at the corresponding y coordinate. So in this first one, my IV is just equal to 3. In my second one, again, this one's a little bit more tricky, but all we're looking for is when that x is 0. What is my corresponding y coordinate? It is -1. So my IV, or my initial value here, is equal to -1. Now the third one is where we get really tricky. Okay? Again, you can pause this and try this one if you want. It's a little bit of a challenge one. But the idea here is what we're trying to do is we're trying to figure out what the coordinate would be when x is 0. What is the y coordinate? So we're going to take a look at what the pattern is, first of all, here. Each time, this is changing by 2 on this side. And on this side, each time it is changing by 4. That's really interesting. So what I could do is I could fill in a piece of this. I'm going to actually write out a new table of values over here and try to fill in the gap. 0, 1, 2, 3, 4, and 5. I'm going to try to fill in the gaps here. Now at 5, we know it's 13. And we know that every time it changes by 2 in the x, it changes by 4 in the y. So that means that from 5 to 3, it's going to go from 13. Whoops. It's going to go from 13 to, it's going to be going down 4. So it's going to go from 13 to 9. Right? We're going, since we're going the other way, we're going down 4, down 2, instead of +4, +2. Okay? If we were to continue this pattern, this one would be from 9 to 1, or 9 to there, right? Going down 2, we would be going down on the right, which would bring us to 5 over here. Now, do you think you know what numbers go in between there? If you think that it is 11 and 7, you are correct. Because if for every 2 we're going down 4, then for every 1, we must be going down 2. Okay, so you're just looking for the pattern here. Now, again, if we follow that pattern, what we will realize here is that at 0, it should be 3. Okay? That is a bit of a trickier one. That would be more of a thinking type question. I can go over that one a little bit more with you if you would like when we're in person. Okay, but again, we're looking for the pattern there. What are we increasing by? So what would we be decreasing by? And we could fill in a little table of values for the gaps that we're missing. Okay? Okay. So now what we're going to do is you have a... I'm trying to think here. Ooh. I'm just realizing that I did not put a space on your sheet for this equation. So what I'm going to say is you either in your... Oh, did I pause that? I don't know what I did. Hopefully we can still hear me. I think we can probably still hear me.
Copyright 2021 Spin Master Paw Production.
Okay, don't really know what happened there. I also don't know if you heard that. But we're going to continue anyways. I think we're all good here. That was interesting. Okay. So what you need to do right now is you need to, somewhere on your page or in your notebooks, copy down these two formulas. Okay, these are very important for what we're going to be talking about next. And I'm just going to read this little blurb here, and then we will continue. So it says here first, that now that we have learned how to find the slope and the initial value, we can combine these things to create an equation for a linear relationship. And what you can see here is you can see our equation. And what our equation says is that our dependent variable is equal to our slope times, right, this is multiplication, times our independent variable plus our initial value. Okay? This can be written a little differently, a little shorter, as this formula here, where y, which is our dependent variable, is equal to our slope multiplied by x, which is our independent variable. Independent variable, plus our, now this is a typo, this should say initial value. My apologies. Okay. Or if we want to write this even a little bit simpler, we can write this as y equals my slope. Do we remember what letter we used for slope yesterday? If you're thinking m, you are correct. So I'm going to write mx plus my initial value, my IV. So you can also write it in that way. Okay? And so what we're going to do is we're actually going to see if we can come up with some equations, or take a look and see if we can figure out some things from our equations. Okay. So this question says, what is the slope and initial value in each of the following equations? Okay. Now, you have another box here beside initial value on your sheets. What I'm going to get you to do is I'm going to get you to fill in some information here. So you have the box and it says constant versus coefficient. Okay? And what we're going to put here is that we are going to put that your constant in an equation is your initial value. And this has no variable attached. Okay? That is what a constant is. I can see I spelt that wrong. And we're going to highlight that one in yellow. Now, if I look over at each of my equations, I can see some constants. In the first one specifically, I'm going to highlight my -5. And so in my first example, my IV is equal to -5. Now, coefficient. What is a coefficient? Well, a coefficient is, in this case, in our equations, this is going to be my slope. And a coefficient is the number in front of a variable. And we should remember this from earlier this year. But for example, 2x, my coefficient is the 2. Okay, so you can add that little piece of information to your note. And this is really important because this is going to, if you know this, if you remember that a constant is your initial value and a coefficient is your slope, this is really going to help you in this unit and next. Okay, so now I can look again at my first example and see that, well, 2 is my coefficient. So that means that my slope is equal to 2. Okay. In my second example, my constant is +7. My coefficient is 5. So that means that my initial value is equal to 7 and my slope is equal to 5. Okay? The variables don't really matter, okay, what the variables are in this case. Doesn't really make a difference here. Okay? When x's and y's are in play, it's a little more important, and you'll see that in our next unit, but d and t, right, distance and time, not really a big deal. Okay, in my next one, I have y equals 0.5x. Well, looking at this, I can see that 0.5 is my coefficient, so that means that my slope is equal to 0.5. Do I have a constant in this equation? Hopefully you're all shaking your heads. No, there is no constant. And since there is no constant, that means there is no initial value. And so my initial value is just 0. Now, if we see what happened in that one, we can connect that to the next one. In the next one, I have no variable. So if there's no variable, there is no coefficient, and which means that 8 is my constant. That means that my initial value is 8, and my slope, well, remember, there is no coefficient, so my slope must be 0. Okay? That's looking at an equation and identifying pieces. Now, what if I give you the pieces and ask you to come up with the equation? Well, we can do that. We're going to write here, for the first one, it's always going to be, and I'm going to put this at the top, y equals your slope times x plus your IV. So in my first one, it's going to be y equals my slope, which is 1/2. I put my variable plus my initial value. In my second one, it is going to be y equals my slope times my variable plus or minus my initial value. In this case, since it's -2, right? My slope slope, slope, my initial value, initial value, initial value, initial value, initial value, initial value. Okay? In my next one, again, we're hopefully seeing the pattern. Y equals, my slope is 0x plus 10. Now, what is 0 times x? 0 times x is just 0. So this is actually just y equals 10. There's my initial value. My last one, y equals 1x minus 1. Okay. There's my initial value. And there is my, and there's my coefficient. Okay. Hopefully we are getting the hang of this. I'm going to go for just a couple more minutes and then I'm going to let you try some questions. Again, I will go over this when I'm back in class to make sure that we all have a full understanding of this. Okay. All right. This is a bit of a big one. Hopefully you have enough space in those boxes there. But basically, if I would just pause the video if anybody needs extra time to get this down. Okay, you can pause the video to write this down. I'm going to start by reading it. And while you have some time to write it down. So it says here that we have two types of variation. We have a direct variation and partial variation. Now, direct variation and partial variation, these ideas, EQAO loves to ask questions about this stuff. Okay, so it's a topic that we'll only talk about briefly. We will kind of talk about it tomorrow again. But it's really important here that you kind of pay attention to what this means, and then we're going to try to remember it. And as we get close to EQAO, we will kind of go over it again. But for direct variations have an initial value of 0. Okay? And I like to think here, and I'll read all the points here, and then I'll kind of give you my idea. It says the graph will start at the origin. It says the table of values will have the point 0, 0, which is the origin. And the equation will have no constant. Very important there. Okay, this goes, and I like to just think that it goes directly through origin. Right, so there's a couple key pieces or key points with direct variation. The most important thing is that the initial value, and I actually should probably put that down, the initial value equals 0. Okay? For partial variation, basically partial variation is everything else. Partial variation has an initial value. Oh, I already wrote that. Partial. Excuse me. Sorry about that. Partial variation has an initial value that is not 0. Very important here. Not 0. It says the graph will start anywhere but the origin. It says the table of values will have a point 0 and B, where B is just anything but 0. B just can't be 0. Any other number. And it says the equation will have a constant. Okay. So again, some key differences there. Okay. So again, if we need more time to copy this down, just pause the video and I am going to continue. We just have a whole bunch of examples here, and we're just going to talk about whether or not these are direct or partial. Okay, here we go. Now, I don't even know. Just trying to look at your homework sheet. Okay, what I'm noticing about your homework sheet is that, what did I do here? Sorry, one sec. What I'm noticing about your homework sheet is that it does not ask you any questions about partial versus direct. And so what I would like you to do for number 3 and 4, before I do these examples, I want you to also tell me if the relationship in numbers 3 and 4 are direct or partial. Okay? We're going to also do this with all the examples that we do tomorrow, but I want you to kind of note that right now on your homework sheet. Determine for number 3 and 4 whether the relationships are partial or direct. Okay? So let's do each one of these. Partial or direct. So look at this one. Where does it go? This one goes through the origin. So this one is direct. It goes directly through the origin. It has the point 0, 0. Okay, that one is direct. We're going to scroll down. We're going to take a look at this one. Okay, again, a little bit of a tricky one here. We can't quite tell if this is going through the origin or not. So what I'm going to do with this table of values is I'm going to make a new table of values again down here. We're going to start 0, 1, 2, 3. We're going to see what the pattern is here. As it goes up by 2, this goes up by 4. Oh, this is the same kind of deal here. So if we're going the other way, it's going back to down 4. So here it said 3, 6, which means if I go to 1, oh, I apologize, jumping around a little bit. If I go to 1, from 3 to 1, my new y coordinate is going to be down 4, which is 2. What's in between 2 and 6? Well, if I'm going down 4 here, if this number right here is just going to be down 2 instead, because it's half. So this is going to be 4. And so what you can see now is that each individual time, now that I've got that filled in, each individual time we're going down 2. If I'm going the reverse way, down 2, right, down 1, down 1. So my last number here is going to be 0. Look at that. This one is also at the origin. So this one is direct. Okay. The next one, let's look at this graph. Where's my starting point? Right here. This is not the origin. So this one is partial. Ooh, look at this one. Remember, my constant is my initial value. So my initial value here is equal to -7, which is not 0. So this is partial. Beautiful. Oh, here we go. Look at this graph. Goes through the origin. Also, you can see that this is an equation. Is there a constant? There is no constant. This is direct. Let's look at my next table of values right here. When x is 0, my initial value is 3. IV equals 3, which is not 0. This is partial. And my last example, ooh, this one's pretty tricky. It's just an equation with all variables. Well, this is a coefficient. Where's my constant? There is no constant. No constant. Which means my initial value is 0, right? This is like plus 0. Therefore, this one is direct. That is all for today. Okay? I hope that you followed along. I know that I rolled through that pretty fast. We are just about to hit the half-hour mark. It is almost 10:30. and I am not feeling great. So I am going to call it a night. I wish you all the best tomorrow. Have a fantastic day. Work away at that worksheet. Work together. Ask each other questions. If you do need to rewind in this video at all, you can do that. The video is also posted on your D2L page, so you can go back and check that out anytime that you would like. Now I'm going to see if I know how to stop this. Okay, there we go. All right, we will see you all later. Have a great day. Goodbye.